Next problem. Before an increase in excise duty on tea, 800% out of 1000 were found to be tea drinker. After an increase in duty, 800 were tea drinkers in a sample of 1200 people. Using standard error of proportion, state whether there is a significant decrease in the consumption of tea after the increase in the excise duty. Right, given sample N1 first, we have taken 100%. Out of that, 800% tea drinkers, right? So N1 equal to 1000. Second sample, out of 1200 people, so N2 is equal to 1200. Out of that, 800 were tea drinkers. So X1 be the person were found to be tea drinkers before increase in excise, that is 800, and after increase in excise, X2 be the number of persons, that is also 800. So we are going to find the sample proportion. So before increase in excise duty, P1 X1 by N1, that is equal to 0.80. P2 is the sample proportion after increase of excise duty. So P2 is equal to X2 by N2, that is equal to 800 by 1200, that is equal to 0.67. So defining hypothesis, null hypothesis, there is no significant difference between before increase and after increase of excise duty. So tea drinkers always same, there is no significant difference. Then H0, H1 is, there is a difference between before increase, after increase, right? So level of significance be 5%, right? Whether there is significant decrease in the consumption, so you can use left tail also. After increase in the this thing, what is that, the excise duty, there is a decrease, so you can use right tail. P1 is greater than P2, like that you can use that also. So that is right tail test. Test statistics, here we are using two tail, right? So test statistics is Z equal to P1 minus P2 by root of PQ by N1 plus PQ by N2, where P is equal to X1 plus X2 by N1 plus N2, 800 plus 800 by 1000 plus 1200, it is equal to 0.7273. Therefore Q is equal to 1 minus P, that is equal to 0.2727. Therefore test statistics Z is equal to, substituting all the values, 0.8 minus 0.67 divided by root of 0.7273 into 0.2727 into 1 by 1000 plus 1 by 1200, you will get 6.806. Calculated value is 6.806 and tabulated value is at 5% level 1.96. So conclusion, comparing both, calculated value is greater than the tabulated value, therefore H0 is rejected. There is no significant difference is wrong. So there is a significant difference, that means a decrease in the consumption of tea after increase in excise duty, right? That is the conclusion. Next problem. In a random sample of 400 students of the university teaching departments, it was found that 300 students failed in the examination. In another random sample of 500 students of the affiliated colleges, the number of failures in the same examination was found to be 300. Find out whether the proportion of failure in the university teaching department is significantly greater than the proportion of failure in the university teaching department and affiliated college taking together. So given sample, first we are taking 400 students, N1 equal to 400 and N2 is equal to 500, right? Affiliated college, that is in the university, N1. X1 be the number of students failed in the university teaching department, right? That is equal to 300. X2 be the number of students failed in the affiliated colleges, that is equal to 300. So P1 is the sample proportion of the student failed in the university teaching department, so P1 equal to 0.75. P2 is the sample proportion of student failed in affiliated college, so P2 is equal to 0.60. That is X2 by N2, that is equal to 300 by 500. So we are substituting the value. Defining hypothesis, there is no significant difference, that is the failure is same on the university department and the affiliated colleges, right? So and that is H naught, null hypothesis. Alternate hypothesis, there is a significant difference. We are using two tail. So you can use left tail also, greater than the proportion they are asking. So P1 less than P2, right? There is a significant difference. Level of significance 5%. Test statistics Z is equal to P1 minus P2 by root of PQ into 1 by N1 plus 1 by N2. Here P is equal to X1 plus X2 by N1 plus N2. 300 plus 300 by 400 plus 500, 0.6667. So Q is equal to 1 minus P, that is equal to 0.3333, right? So test statistics Z is equal to, substituting the values, 0.75 minus 0.6 divided by root of 0.6667, 0.43, right, into 1 by 400 plus 1 by 500, 4.7468. So conclusion clearly, calculated value is 4.7468, tabulated at 5% 1.96. So calculated is greater than the tabulated, therefore H naught is rejected. So there is a significant difference, right? Thanks.